Hi, and welcome to my third try at 4.3 graphing. I've got a little warm-up question here, so take a second if you'd like. Pause the video and see if you can figure out what is the slope of the following graph. I'm just going to change my pen. I think it's a little bit easier to see red. If it turns out that I am wrong, let me know. So slope is still, like always, m, which is rise over run. In order to find our slope on this one, what we can do is we can pick 2 points. I'm going to pick, say, this point and this point. The only reason I'm picking that point is because it goes through nice markings. The hash markings really nicely. Any point that goes through the hash marks really nicely will work. In order to get from point 1 over here to point 2, I would have to go up 1, 2, so my rise is going to be 2, and my run is going to be 1, 2, 3, 4. So my rise is going to be 4. As always, we're going to take a look at our fraction. If we can reduce, we will. Turns out we can divide top and bottom of these fractions by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So our slope in this case is a half. So there isn't a ton of new content that happens in 4.3. It's just some examples we're going to go through. There's 1 or 2 new words we're going to learn about, but that's going to be about it. So graph a line with a slope of 3 going through the point -4, 3. So in order to do this, what we're first going to have to do is we're going to have to find the point -4, 3. Keep in mind that the first one in our set of points is always an x-coordinate, and the second number in our pair of points is always our y-coordinate. So our x-coordinate over here, we're going to go left because it's a -4. 1, 2, 3, 4. So this is our point right there, -4. And then we're going to go up 3. 1, 2, 3. So that's our point right there, -4, 3. And we're looking for a slope of 3. So if our slope is 3, it's easiest if we think about these as fractions. So our slope is 3. To write that as a fraction, it's exactly the same as 3 over 1. And as always, that's our rise over run. So from that point, we're going to go up 3, 1, 2, 3, and then we're going to go over 1. And that'll be another point on our line. And we can keep doing this if we'd like. 1, 2, 3, over 1, rise over run, 3. And there we have 3 points that are on our line. So then what I like to do is I like to get my ruler tool. If I can move slowly enough. Sometimes I go too fast, it doesn't like it. And then I can connect my 3 lines with a ruler line. Bam. And there's our line that goes through our original point, -4, 3, and has a slope of 3 over 1. Couple more examples. Graph a line with a slope -1 over 4 through the point -6, 2. And show counting both ways. That's just a little note to myself to remind me what to talk about for this example. So it's written a little bit oddly in the question, but our slope is a fraction this time, -1 over 4, which again, we just think about that as rise over run. And it goes to the point -6, 2. So I'm going to move a little bit faster. We're going to find the point -6, 2. 1, 2, 3, 4, 5, 6. And then 2, 1, 2. So this is our point right here. And then our slope. So -1 divided by 4 is our slope, which means our rise is -1. So all that negative means is instead of going up, we're going to go down. So I go down 1 and then run 4. 1, 2, 3, 4. And there's another point. And again, I like at least 3 points. And then if those 3 points aren't on a line, I've made a mistake. I go down 1 over 1, 2, 3, 4. And there's my slope. And I can get my ruler out. And I can connect all those dots. My ruler's fighting back a little bit. There we go. And there is our slope our line through the point, -6, 2. That was our original point. And then our slope of -1/4. Now, if we look at a slope, or if we look at a fraction, it's always the same if we multiply the top by a number and a bottom by a number. So I'm going to see what happens if I multiply the top and the bottom by -1. -1 times 1 is a +1, and 4 times -1 is a -4. So -1/4 is then the same as 1/4. So if I want to use this as stead in our slope, so this is counting the other way, I can use this too, and I should get points that still end up on this line. So if I start at our original point, that's this one over here with the dot on it. So now I go up 1, so I'm going to go up 1, and then it's a -4, so I'm going to go left 4. 1, 2, 3, 4, which would give me that point right there. And we'll see that if I get my ruler tool back out, and I draw my line through those 3 points again, that this fourth point now also is still on that exact same line. So both of these, -1/4 and 1/4, are the exact same slope. And that might come in handy for our next example. Graph a line with a slope of 2 divided by 3. So again, I can write that out so that it doesn't quite look like it's a slash. Instead, it looks more like a fraction. Through the point 9, 9. So if I go to the right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up at this point right here. And we'll notice if I try and go up 3, or up 2, because my rise is 2, and my run is 3. If I go up 1, 2, I'm off. And if I go over 3, 1, 2, I'm off again. So this slope isn't necessarily the most useful, but what I can do is the exact same thing as I did in my last example and multiply the top and the bottom by -1, and then I get -2 over -3. So now if I go back to my point 9, 9, and -2 for my rise means I go down 2. 1, 2, and then -3 means I go left 3. 1, 2, 3. I can do that again. 1, 2, left 1, 2, 3. I get my 3 points. I pull out my ruler. I connect all 3 points, and then I can just keep going. There we go. There is the line that goes through the point 9, 9 and has a slope of 2/3. So what we're going to talk about next is intercepts. We have 2 intercepts. I'm going to try and do this in 2 different colors. I have an x-intercept, and this is where a line crosses the x-axis. Crosses the x-axis. So this is our x-axis. This is the one that goes left and right. So where this line crosses the x-axis is right here. So this would be our x-intercept. And this is the point. 1, 2, 3. I go left 3, and then I don't go up or down at all because I'm on that x-axis. So my x-intercept in this case is -3, 0. I also have a y-intercept. And I think you guys can guess that this is where the line crosses the y-axis. This, of course, is our y-axis, which means that this is our y-intercept. And it's at the point up 2, and it's left and right 0. So this is at the point 0, 2 is where our y-intercept is. So notice how on this one, and for all y-intercepts, my x will be 0, because if I'm crossing that x-axis, my x value is always going to be 0. And similarly, for our x-intercept, our y will always be 0. Okay, so that's a pretty general line. It crosses both axes. And there's actually two special types of lines that only cross an axis once. So take a second, see if you can think of what types of lines would only cross the axis once. So if you thought a vertical line, so I could do a straight up and down line, I'll do one over here in green, a vertical line only has a x-intercept. And if you're thinking ahead, I'm going to do this next one in, let's go purple, because purple's kind of fun. A horizontal line would then only have a y-intercept. So if I've got a horizontal line, I go straight horizontal, horizontal line only has a y-intercept. And that would be right there for my horizontal line. And if I go back to green, oh no, let's go back to that shade of green. This is my x-intercept. Those are subtly different, but that's okay. So that's our x-intercepts and y-intercepts for an angled line, horizontal line, or vertical line. So let's talk about those a little bit more. So we're going to go back to an example 4. Determine the x and the y-intercepts of a line with a slope -1/5 through the points -5, 3. So we're going to start this question exactly the same way we did our first two examples. I've got a slope, and I can write that as -1/5. So it looks a little bit more like a fraction than it does in the question. And it's going through the point -5, 3. So I can find the point -5, 3. 1, 2, 3, 4, 5. And then up 3. 1, 2, 3. So there's my point -5, 3. Now my slope is -1, 5. So I go down 1 over 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. And I'm going to do one more, down 1 over 1, 2, 3, 4, 5. And then I can get my handy dandy ruler out. And I can connect my dots again. Cool. And I can see quite clearly that this is my y-intercept. And this is my x-intercept. And this green is hurting my eyeballs, so I'm going to change colors. Let's do blue. So my y-intercept is 2, and my x-intercept is 10. You can also write this if you want, and some people do. For my y-intercept, my x value is 0, my y value is 2. This is an or my x-intercept is 10, 0. Both of those work. Example 5, determine the slope of a line with an x-intercept of 5 and a y-intercept of -3. So I look at my x-intercept. My x-intercept is going to be 5. 1, 2, 3, 4, 5. And I can put a big dot there. My y-intercept is going to be -3. Down 1, 2, 3. I can put a big dot there. And then I can take my ruler again and I can draw a line connecting those dots. And what I'm trying to do is I'm trying to find the slope of this line. It turns out to be super convenient because it's given us 2 points on the line where the line nicely goes through the lines of my grid. So what I want to do, again, slope, rise over run. I can start at point 1 and go to point 2. In order to go from 1 to 2, I go up 1, 2, 3. My rise is 3, and my run is 1, 2, 3, 4, 5. 3 over 5. And then I'm going to pause for a second and say, can I reduce that fraction? No, it does not look like I can reduce that fraction. So there's the slope of my line with a x-intercept of 5 and a y-intercept of 3. And I think that is the end of 4.3. And if we are super lucky, we'll be able to get this uploaded, and third try's the charm.